This is a very interesting problem because it shows us like two angles and it's kind of funny. Okay, so we know that the ramp in which this block is moving up this has an angle of 15 degrees, but someone is pulling it with 40 degrees respect to the horizontal. Thing is that if you trace a line here all over the place that is parallel to the surface, you're going to notice that this angle over here is 15 degrees. So this other angle over here is 25 degrees, okay? So this is respect of the surface in which the box is moving, okay? That's the first thing to notice. And well, let's trace a nice free body diagram after this. So we get to know that from here, you have the force going this way. You have a normal force going up like this, and you got the weight going down, okay? And the angle is gonna be this one over here. So let me retrace it all the way around. Here, just the normal force, the weight's going down, and this would be the x-axis, but there's a force going on here, okay? This would be the y-axis, and here this angle is of 15, and this angle is of 25 degrees. Okay, so there you go. This is the force, this is the normal force, and this guy over here is the weight. Okay, so let's settle the equations out for this. Well, the sum of all the forces in x is gonna be the force cosine of 25, and thing is that's gonna be minus the weight sine of 15, and it's gonna move, so this thing is equal to mass times acceleration, and the sum of all the forces in y, it's gonna be equal to the normal force plus the force sine of 25 minus the weight cosine of 15, and it's not gonna move on the y-axis. Okay, so we can just leave them that way, and they're gonna work good enough for us. So we need to know the smallest force until this thing moves. So we need to find, when you're told this exact question, let me say, what is this thing? Smallest force. Okay, you need to settle the equation such that this thing is in balance. How do you know that this thing is in balance? By saying the acceleration is gonna be 0. Okay, so this whole thing over here is gonna be 0. Okay, that's the minimum force for you need to apply for it to stay in balance. So something a little bit bigger will make this box move. Okay, so that will simplify our equation. That will leave us with the force cosine of 25 minus the weight sine of 15. It's going to be equal to 0. So the force is going to be equal to the weight sine of 15 over the cosine of 25, and this thing, the weight is like 20 times 9.81 times the sine of 15 over the cosine of 25, and this thing is going to be equal to 56.03 newtons. Okay, so there you are.